Okay, so to understand what is polarization, first of all we'll have to start with electromagnetic waves, right? Because polarization is a phenomenon that happens with waves. Let's start. Do you remember that in EM wave chapter we took one particular case where suppose the wave is traveling towards the x direction and we wrote the equation of the electric field would be something like E0 sine omega t minus ax because it's traveling in the positive vector. And then here j cat. And similarly for b vector blah 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 k cat. At that time, while writing this equation, I told you that this is not the only possibility. Do you remember that? Okay. So polarization is related with that sentence. Okay. So E vector is E0 sin omega t minus kx j cat. That is one of the many possibilities. If you remember, I told you that anything that gives this relation is okay. And E hat cross B hat should give C hat. Then that is fine, right? Okay, so let's see what are the different possibilities. And I have 3 pens. So suppose this pen is C vector or C hat. So एक तो possibility आप पे draw करिए. Blue is electric field. Okay, this is electric field. This is magnetic field. There is also one more possibility. जो बधाમાં E cross B C જ આવે છે. Do you now recall what I explained at that time? There are actually infinite number of possibilities. ગમે angle for it. Okay. Barabar. So now what happens is when you take any ordinary light, let's say this tube light, okay. So when you take ordinary light, what happens is that let's say you are watching this. The wave is coming towards you. So when you see it, you are going to see that the electric field is either in the j direction or here or here or here. It could be anywhere. Do you understand what I am saying? આ ખબર પડી ગઈ? આમથી જો તો કેવું દેખાય? Got it? Now, because the light that we receive, આ tube light માં કેટલા બધા atoms હશે which are emitting radiation. Don't forget, radiation comes from atoms. That's what we have learned in the chapter atoms. When the electrons make transition, you get radiation. Barabar ne? Source of radiation is atoms. Okay? So there are so many atoms emitting that radiation. So badana electric field vectors આવતા છે નથી. All those may not be in the same direction. That is, they are randomly oriented. This is called unpolarized light. एक atom નું આમ હોય, બીજાનું આમ હોય, બીજાનું આમ હોય, like that. So when you receive this light, the electric field that comes with it is not necessarily in only one direction. આવી રીતે ગમે તે direction. And the light is coming towards you. Can you imagine that? Got it? We are not even talking about P vector. E નું આવી ગયું તો B નું આવી ગયું. Simple. Right? They are just at right angle. Okay? We will not talk about B vector anymore in this topic. So this is called unpolarized light. Look, draw color. This is what it indicates. Electric field vectors randomly distributed. That is called which light? Unpolarized. જો આ ટોપિકમાં બહુ બધી થિયરી છે. ઓકે, એટલે ઊંઘી ન જશે. એ ફટાફટ કર. People understand we do not have luxury of time. એટલે આમ હાથ તો ઉતાવળો જ ચાલવો જોઈએ, આમ ફટફટ લખાવજો. ઓકે, ફર્ગેટ અબાઉટ હેન્ડરાઇટિંગ. હેન્ડરાઇટિંગની ચિંતા તમે છે ને એપ્રિલમાં કરી લેજો. બરાબર ને? ત્યાં સુધી કોણ હેન્ડરાઇટિંગ જોવાનું છે? Okay, so that is unpolarized light. Now, you see, there are some substances. There are some substances which are optically active. Okay. Now, what happens is that when from such a material light will pass, okay, unpolarized light becomes polarized. Okay, there are some substances, some chemicals, some materials that convert unpolarized light into polarized light. So what is polarized light? I would know. It is in only one direction. There are actually different kinds of polarization, but the most basic or the simplest kind of polarization is called plane polarization or linear polarization. Okay, so don't worry about all the different names. Yes. Yes. Okay, so what is plane polarized light? It would be that electric field vectors are all oriented in only one direction. समझी क्या? All electric field vectors are oriented in one direction, then that is called plane polarized light. In fact, this equation is an example of plane polarized. Which are suppose R possibilities. You reject all the other possibilities. What do you get? Light આમ જાય છે, electric field કઈ direction માં આવશે? એક જ લાઈન માં આવશે ને? Only on which axis? Y axis. Very cover. So if you just say this equation, then this wave is actually a plane polarized wave. समझाओ कि ना समझाओ? Right? Because the only writing this means all the E vectors are in the same direction. Do not consider this. Don't worry about this. Okay? E આમ હશે તો B આમ આવી જશે, whatever direction possible. Don't worry about that. Did you understand? Do not worry about B. Just think of E and everything will make sense. Okay? So this is what is called polarized light. Okay? So after plane polarization, this is what happens, and this is called which light? Polarized. And the meaning to that, all E vectors are on the same what? Line or same direction. Undai hoy. Please don't think that shouldn't these two cancel each other. No. Because they are from different atoms. Okay, and you see, light at its very heart is having quantum behavior. એટલે આપણે જેને આમ continuous stream of light કહે છે ને એવું ન હોય. Every photon will come with its own electric field in different directions. જે મારી આંખ ઉપર એક ફોટોન ભટકાશે તો એનું ઇલેક્ટ્રિક ફિલ્ડ આમ છે, બીજો ભટકાશે તો એનું આમ છે, પછી થર્ડનું આમ હશે. Like that there is randomization, that's why it is unpolarized. અને એ randomization જો જતું રહે, then it becomes clear. That's what polarized and unpolarized. એટલે અંદર હજી જાઓ તો ઘણું ક્વોન્ટમ મિકેનિક્સ આવી જાય. Even electrons can be polarized. Electrons can be polarized, right? Okay, now let's go to the next thing. How do we create this kind of polarized light? Okay, so there are three ways. Number 1, 2, 3. Number 1 is by using Polaroids. Okay, so again, Polaroids are those kind of devices or materials through which when light will pass, it will get polarized. Understood? That's called a Polaroid. There are different kinds of Polaroids and possibly 100 of them. Don't worry about names or anything. Okay? Right? Number 2. You can also do it by scattering, and you can also do it by reflection. Okay, so there are 3 ways to polarize it. This is completely theory. I will તમારા માટે છોડી દઉં. Okay, read it by yourself. It's theory. Read it by yourself. Mostly you will understand. If you don't understand something, feel free to ask. Okay, એના સમ બહુ રેરલી આવે છે, but for theory based question પૂછી લેતો હું તો પૂછી લઉં. That doesn't mean it is there on the next test. So this is for you to complete. આ બે કરાવી. Right? Okay, now, so what is it with Polaroids? So let's start with Polaroids. I think you should draw.
Yes.
So Polaroids, again, why do they polarize? That the answer of that why lies in chemistry. આપણી બાજુ બહુ નહીં. Understood? Like for example, you take some Polaroid, light passes through that, then why does light get polarized? So what happens on the inside is due to chemistry. But I'll still give you a very basic, very simple idea. Is that suppose electric field vectors are in all possible orientations. Okay, I'm trying to draw a 3D diagram. This is in 3D. Okay, you are watching it from the side and light is going in this direction. And let's say here is a Polaroid. Okay, here is a Polaroid. So what happens is that for light to pass through a material, its charges, whatever material there is, it is made up of atoms. Atoms have charges. So when electric fields will fall or electric fields will be created here, like I'm outside, electric field will be created. At that time, if the charges oscillate only in one direction, then on the other side you will get polarized, right? Reason is simple. Suppose this is a charge. Okay, a pair of charge, actually a dipole. So આ point પર electric field કઈ બાજુ આવશે? Do you agree it will be in this direction? Electric field on equator. Yes or no? First chapter. Check પહેલાથી electric field on equator of dipole. Okay? આનું આમ આવે બેનું resultant વચ્ચે આવે. ચલો. So if it's like this, then electric field is created in this direction. Suppose this charge oscillates. Oscillates मतलब a negative charge आम जाए, positive charge आम जाए, ऊपर नीचे जाए. What will happen to this electric field? It will also oscillate. याद आया? This is how electromagnetic waves are created. समझे ना आप? Okay. So this electric field will also go up and down, up and down. Its value will change by this equation equal to E0 sine etc. So, do you see that if charges oscillate in this direction, y છે? Y છે ને? So electric field એ y direction oscillate થાય. Fine. Wave will travel towards x. Got it? Sure. अच्छा, z direction માં wave travel થાય, આમ જાય wave. Then does electric field oscillate in this direction? The answer is no, because electromagnetic waves are transverse waves. Yeah, okay. So in fact, one of the basic ideas of polarization is that polarization can only be done for transverse waves, never for longitudinal. You know, मतलब कि electron waves are transverse waves. Right? One more strange statement if you think about it. But पाछा आवी जाओ topic पर. So this will go up and down. Electric field follow similarly wave arm transverse nature. Now if you think of this material, let's say this material, listen to this carefully, let's say this material is such that molecules are such that the charges can only oscillate in this direction. Suppose the charges can only oscillate in one direction. So when this wave will come here, the particles or the charges of this material will only oscillate up and down. So bar the electric field equals to arm. Did you understand? What will happen to the others? It will not go through. Got it? Think about it. Ana charges and they will not go tilted. Let's say only like this. Then the electric field that's created in front of it is only going to be in one direction. If these would be moving randomly, suppose आमे जै सके तो सुधा. Then you will get unpolarized. Got it? So at the heart of all these there is some chemistry, frankly, right? Okay, but like I said, this is the basic idea that there is some restriction on oscillation inside molecules. That's why we get polarized. So now if this will go through it, here you will get polarized. So this is unpolarized, this is unpolarized. When it goes through it, this will become polarized. This diagram clear? Diagram clear or not clear? This line that I have drawn here is called path axis. What is it called? Path axis. Path axis means it passes in that direction, blocks in the other direction. Got it? Passes the electric field in that direction, blocks it in the other direction. Okay, so actually what happens is you get components. Right? Okay, whenever electric field arrives over here, you get components. Let's say you are watching this from here, a path axis. Okay, and suppose some electric field vector is like this. Suppose some electric field vector is like, and it is making an angle theta with this. So E na બે component hai, correct? Understood? Which will pass, which will be blocked. Which will pass, which will be blocked. E cos theta, pass. E sin theta, block. Okay? Sure?
Yes.
So what will happen is overall for all these components, for all these electric fields, their horizontal, suppose this path axis is vertical, their horizontal components will all get blocked. Only by the vertical. Got it? Suppose you rotate the Polaroid and make the path axis horizontal. So only by the horizontal, vertical block. Get the complete idea about this?
Yes.
Okay. Now, another interesting thing. In which case will intensity of light be more? Here or here? Input or output? In which case will intensity of light be more? Input or output? Input. Do you remember that intensity is proportional to square of amplitude of the electric field? Light electric field. Okay? So that's why here obviously you are blocking the electric field. So do you agree with me? Why? Because only a component goes through. And E also. And through they will say E cos. Got it? Okay. Now let's take this further and derive something. Okay. So you can say that for one electric field, for one electric field, only E cos theta goes through. For one electric field, only E cos theta goes through. So do you agree that IT upon I0, IT એટલે transmitted intensity, I0 એટલે original intensity. Okay? Symbols clear? Original intensity, transmitted. Incident, transmitted. Okay? It's not a vector. We'll see. Don't consider it's a vector. So IT by I0 is equal to. Is this clear? What relation are we using? Intensity is proportional to the square of. Clear or not clear? Okay, obviously E square is going to get cancelled. So anybody relation? IT is equal to I0 cos square. Right? Okay. Now, just hold on for a second. This is only one electric field, but in unpolarized light, do you think we have only one electric field, one direction? No, there are hundreds of different directions. Make sense? Integration, exactly. Right? We will do integration. So what you'll have to do is, when you do integration over the whole circle, that is 360 degrees, it's like doing it over one cycle. Remember that? Wherever we are using shortcut, my karawa to bada step karawa, but time nathi. એટલે બોલીને પૂરું કર. I'm saying that when we do integration over the whole cycle, it's going to average out cos square theta, correct? So cos square theta ni average over one cycle. Wait. So you have these final things. If unpolarized light passes through polarizer or Polaroid, there are two names. You can either call this polarizer or Polaroid. IT equal to I0 by 2. बराबर ने एवरेज करो तो सो I0 by 2. Got it? What is IT and what is I0? IT for what? Transmitted intensity. And I0 for incident intensity or original. Alright? Do not forget this. Our word magadbad kari to undu thai jase. Again, why did we take average? Because we know that in unpolarized light it will be everywhere. Here, everywhere. So we have to take average of cos square theta. Surendra uthi ja. Okay. बहुत राधे भणतो लागे तो that's it. Now what if, let's take a slightly different case, easier one. What if this was not unpolarized, not unpolarized, that is suppose the light was already polarized, એક જ electric field આ direction માં જ વધતો સુધા, then would we have to do integration and average? I'm asking you, suppose instead of unpolarized light, this was polarized light, so that electric field is only in one direction. Yes? Clear? If it was polarized light, electric field would only be in one direction. Would you need to do integration and average? No. So formula શું બની જાય? એ ઉપરનો step. બરાબર ને? તો એ સ્ટેપ લખો. If polarized light passes through polarizer or Polaroid, નાથી polarizer છે. બ્રેકેટ માં લખજો analyzer. Why it is given such a name, I'll explain very shortly. Now here it is very important to write the terms, especially theta. દેખાય છે અહીંયા સુધી? એ ઉપર લખો. What is theta? What would you label theta as? Look at this diagram. What would you label theta as? Angle between path axis and the electric field of incident. Okay, look now barabar. Angle between path axis and electric field of incident light. Sorry, angle between path axis and electric field of incident light. Please everyone do draw this diagram. Okay, neither તમે પછી ખાલી સેન્ટેન્સ વાંચો ને તો તમને કઈ ખબર નહીં પડે. So optically active compound can actually rotate this electric field. Rotate એટલે શું કરે ખબર છે? રોટેટ ન કરે, કોમ્પોનેન્ટ કરીને એક કોમ્પોનેન્ટ ઉડાડી દે એટલે આપણને એવું લાગે કે રોટેટ. ફોર એક્ઝામ્પલ, if I say that velocity is in this direction, આના બે કોમ્પોનેન્ટ થાય. સપોઝ એમાંથી આપણે એક કોમ્પોનેન્ટ ખાઈ જઈએ તો ખાલી આ જ રહે ને તો આપણને કેવું લાગે? વેલોસિટી રોટેટ. મેક સેન્સ? there is something similar happening in those cases, right? Electric field હોય એવા sound હમણાં આવશે where it will rotate. Okay, but not like you have it in chemistry. Chemistry માં હોય કે આટલી લેન્થ છે ને આટલું કોન્સન્ટ્રેશન છે. એવા શું થાય કે નહીં? PPL હા એ રીતે. PPL એટલે પ્લેન પોલરાઇઝ્ડ. બરાબર ને? Okay, done with this? Yeah, this has a name. This is called Malus law. આ જે સેન્ટેન્સ લખ્યો છે ને, Malus was the name of a person. Okay, it is called Malus law. આ નહીં હો, આ બેમાં ફરક દેખાય ને તમને કે નથી દેખાતો? એ ભૂલી ન જતા. ઘણીવાર એના ઉપર કન્ફ્યુઝિંગ ક્વેશ્ચન આવે છે. So this is Malus law. That is not Malus. Okay. Now why is it called analyzer? Let me explain. See, suppose this was already polarizer. You draw a new diagram, everyone. You polarized light draw karna ko. Don't be lazy. So let's say when it falls here, we get an angle theta. Okay. So how much intensity we get here? What does that depend on? Can you answer that question? Suppose this is I0, then how much intensity we get here depends on what? Theta. I0 पर तो depend करे. Okay, right. And it will depend on theta. Agreed? હવે તમે આને પકડીને આમ ગોળ ગોળ ફેરવો તો શું થાય? સ્ટીયરિંગ વ્હીલ છે. Theta will change. If theta will change, then intensity will change. So you will come to know that this light is polarized. Polarized. Unpolarized હોય તો શું થાય? Look at this. In unpolarized, if you rotate it, what will happen? Nothing will happen. Do you get what I am saying?
Yes.
Look at this. IT is always I0 by. Make sense? It does not depend on angle. Clear? Doesn't depend on angle. So if the light that is coming through is polarized and you rotate it, intensity will change. If it is not polarized and you rotate the Polaroid, then intensity will not change. હવે સમજ પડી કે મેં analyzer છે, because it checks or it analyzes whether the light is polarized or not polarized or unpolarized. સમજાણું? Analyzer is the second polarizer or Polaroid. એટલે એકવાર unpolarized passes through Polaroid becomes polarized. Then you put something that will check whether it is polarized or okay. એટલે an analyzer. Now I want you to write 2 or 3 important sentences. Okay, I'm erasing this part. एकदम simple છે પણ આના questions કોકર આવે. Okay, here we go. It is that number 1, if unpolarized light is passed अच्छा આ format મને તો remove it. I'm so sorry. Let's write it in a nice way. So upon rotating the Polaroid by 360 degrees, attendance is optional. Upon rotating the Polaroid by 360 degrees, what do we get? Number 1, if the light is unpolarized, if light is unpolarized, what happens? No change in intensity, in IT. Okay. Second, if light is completely polarized, completely polarized, so how you know? Completely polarized means polarized. Okay, there is a middle ground. If light is completely polarized, then what will happen? See, when you rotate it 360 degrees, think about it carefully. I actually am rotate on. So do you realize that there will be one time when this angle will become 0? એટલે જ્યારે maximum થાય. Agreed?
Yes.
પછી આમ ઊંધી બાજુ જતું રહે. So there will be one more time when the angle becomes 180 and cos 180 is still -1. So square કરો તો +1. So you get maximum intensity. So how many times do we get maximum intensity?
2 times.
2 times. Who understood that? One time for 0 degree and one time for 180. And how many times will we get 0 value of intensity? 2 times. For which angle? 90 and 270 or -90. Never mind. So write it. So if light is completely polarized, then intensity becomes maximum. IT becomes maximum twice and 0 twice. Did you understand this sentence? IT becomes maximum twice and 0 twice. And now the third one. If light is partially polarized, what's this? Let me explain that first. What's meaning of partially polarized? To understand what is partially polarized, go to this one. Unpolarized means all electric field vectors, they are going to behave or they are going to be oriented in completely random direction. So when something is completely random, overall it's all equal in every direction. Do you agree? What is the meaning of random? So you know, nature will average it out. Correct? Right? So in unpolarized light, there is no preferred direction. Do you understand that sentence? In unpolarized light, there is no preferred direction and all electric field vectors are randomly oriented. There is no preferred direction. કોઈ પણ એક ડિરેક્શનમાં સેમ જ હોય બધી બાજુ. In completely polarized light, all the electric field is in one line and there is nothing else on the other line. Okay, so there. Now, what's the middle ground? It would be something of this kind, that electric field is more on one line. Let's say y-axis or y components are more, but x components are smaller. You get what I'm saying? So this light is neither completely polarized and it's also not unpolarized. Okay, unpolarized no guy. Unpolarized by definition would mean there is no preferred direction. कोई direction में कोई फर्क ज नहीं. That is called unpolarized. It should be same in all ways. Is that the case here? No. Y में बदल. X more. Got it? So this kind of light is called what? Partial. Make sense? Everybody then? What's the extreme case? Totally polarized. As our nano saying is 0 0. How can we get partially polarized light? By reflection, we can get partially polarized light. Okay, यदि आगे आओ से अत्यंत नहीं लोग चल, right? So this is what is partially polarized. आमा जो है, will intensity ever become 0? Think about it. Suppose path axis is like this. Will intensity be 0? No. Suppose it's like this. Then also will it be 0? Okay, हम तो है. So in any direction it won't become 0. But yes, there will be maximum and there will be minimum. So our sentence. But IT becomes maximum twice and minimum twice, but not. Okay. IT becomes maximum twice and minimum twice, but not 0. Right? But not 0. Can you change? Maximum twice, minimum twice, but not 0. Am I the maximum twice, minimum twice, but 0? Right? Done? Again, I repeat the sentence. IT becomes maximum twice and minimum twice, but not 0. That is called partially polarized, and that's how you check it. Okay. Now this is by Polaroid. Scattering तुम्हारे करना है. Third one, reflection. That is polarization by reflection. Here once again we have something extremely simple. Okay, and what we are going to derive or what we are going to discuss is called Brewster's law. Okay, पहला समझाएगा. Let's say these are two transparent media, medium 1, medium 2. Okay, with their own refractive indices n1 and n2. And suppose a ray of light is incident. I'm saying it as a ray, but you know it's a wave. Now when this light wave will come in this direction. So the electric fields are going to be, assume this is unfolded, right? To start, that will make it very easy. Suppose this is unfolded. So electric field by direction, light is traveling in this direction. So do you agree electric field may be like this in the plane of board? And the second possibility is like this, components karine. Actually it would be random, but we are just thinking of component, right? This is wave, okay. So the ones that are in the board, I am indicating them by arrows like this. This is a traditional way to indicate. And the ones that are out of the board or in the board, that is in 3D, એના માટે dot. ઓલા જેવો છે ને dot cross આપણે કરતા હતા magnetic field. Understood? Dot means what? Coming out or going in. 3D માં z axis. Okay, and arrow તો તમને દેખાય છે. Clear? So there are two components of the electric field in this unpolarized light. Now what happens is, think of a particular case. Okay, think of a special case such that if this is angle of incidence, right, some of the light will get reflected. I'm sure you all understand that whenever light hits a transparent media of other refractive index, there is definitely some reflection. Right? There is also refraction because it is transparent. Okay, so let's say this is refracted. Now we are talking about a special case where this angle is 90. what will happen at that point? You see, the electric fields that are coming over here will reach this point. And અહીંયા oscillate થશે particles. કોના particles? Suppose this is air and this is glass. Glass particles will oscillate. But do you realize that because of the arrow electric field, they will oscillate in this direction? I draw here, maybe I draw it with blue. My time. I'm saying that these arrow જે છે અહીંયા આવશે તો આમ oscillate થશે. Okay, right? But do you remember that if the charges oscillate in this direction, wave armed, correct? So if these charges are oscillating in this direction, આ બાજુ જાય, that would mean it would become longitudinal. Do you understand? Yes or no? Who got it? Think of it. આ ચાર્જ ઉપર નીચે થાય તો electric field આમ થાય. Electric field આમ ન થાય. Right? Also the wave doesn't go in this direction, it goes in the perpendicular direction. So that's why the electric field that causes oscillation in this direction doesn't reach here. Who got that? The electric field that causes oscillation in this direction doesn't reach here. Yes or no? And આ 90 degree હોય તો થાય. Do you realize that? It's due to geometry. Suppose it was not 90 degree. Right? Suppose આ આમ હોત અને આ આમ હોત. આ refracted and reflected. So આના component આમ થાય. You see, they can go in this direction by a component. Okay. So when this happens, clearly this angle is R, refraction angle. What is something you? A 90 degree. So do you agree that only dots will go here and cross arrows will not go there? इसमें समझे ना कि arrows will not go there, only dots will go. अच्छा तो आ लाइन क्यों है कि polarized है ना? Do you realize what I'm saying? The arrows have been cut off. So this reflected light has become which light? Polarized. Okay, but when will this happen? When will this happen? Only when this angle is 90. Understood? As your sentence this will happen when this angle is 90. That sentence is called Brewster's law. Okay. Now let's derive the expression. Yeah, I'm gonna lock out. Don't worry about that. I'll make you write the law. Yeah. So let's go here. Geometry बहुत simple है. I plus 90 degree plus R is equal to 180 degree. If you have questions, go to 7th standard. Therefore, I plus R is equal to 90 degree. Right? So now if I use Snell's law, over here, N1 sin I is equal to N2 sin R, right? Yes. Snell's law? Yes. Instead of sin R, I plus R 90 है, तो sin R की जगह cos I लगा. Complementary angles, do you see that? Yes. Alright? So this will become, therefore, N1 sin I is equal to N2 cos I. Sin R is equal to cos I. Fine? Yeah. बराबर है? Therefore, N2 upon N1 is equal to tan I. Okay? Right? So now let's write the law. If reflected ray and refracted ray are perpendicular to each other, the reflected light, what do we know about reflected light? It is completely polarized. Highly polarized logo chale, but just to be more specific, it is completely polarized. Okay, this sentence is called Brewster's law. Okay, this is called Brewster's law. Now, based on this, we derived all this. So this angle is also called Brewster's angle. The angle of incidence in such case is called Brewster's angle. એટલું સ્પીડમાં મેં કેટલા ટાઈમથી લખ્યું છે. Okay, so what we have derived is the formula of Brewster's angle. Thus we get tan theta b is equal to n2 upon n1. Our formula Brewster's angle. Okay, again what is 1, what is 2? Our usual convention. याद से light comes from 1 and goes into 2. Simple, right? There is no worry about rare or denser here. Let me tell you that. There is absolutely no worry about rare or denser. Okay, you can विचारसो नहीं चालतो. So that is Brewster there. Now just one minor point. This is polarized light, very good. What about this? Is this polarized? No, it is only partially polarized. થાય એવું કે ડોટ્સ બધા આમ જાય, બધા ડોટ્સ આમ ન જાય. You get what I am saying? ડોટ્સ બધા આમ જાય પણ બધા ડોટ્સ આમ ન જાય. No, not clear. Let me clarify. What I mean is that here no arrow will go, okay, but over here both will be able to. તો હું ખોટું બોલ્યો ને, મને એવું લાગે છે ખાલી ડોટ્સ જ આમ જાય, right? That's what we have. Fine, this is clear. So this light is polarized light, but this light is partially polarized. Okay or not okay? Sure, absolutely clear. કેમ partially polarized છે ખબર કોઈ? થોડા ડોટ્સ આમ જતા રહ્યા ને તો એક ડિરેક્શન ફેવર થઈ, right? The arrow is favored. Okay, just one more thing. What if this is not 90? So our light no sudah. It will be partially. Okay, if this is not 90, then that light is also partially polarized. Be partially polarized. Right? Basically, reflection always polarizes. Reflection always tries to polarize. And at 90 degrees, this polarization is complete. For other angles, here 90 no hai to. For other possibilities, it is not. Got it? चलो बस હવે બહુ થઈ ગયું. બરાબર ને? Let's stop the theory here. હવે scattering નું તમે વાંચી લેજો. It's similar to this idea. I'm erasing it. Now time for very simple questions. Polarization of question simple by definition. Diagram is shown. This light is incident at what angle? 30 degrees. Reflected light is completely. Then what do you have to find? Critical angle. Okay, give it a try. That's the more immediate question of now. આ ક્વેશ્ચન લખવાનું રહેતા હોય એટલી વારમાં સોલ્વ થઈ જશે. ડન. વોટ ધ આન્સર? sin inverse નો સમજાણું 1/√3. ઓકે, એક કે બે સ્ટેપમાં પૂરું થઈ ગયું ને. just relate the thing. Completely polarized reflected light means this angle is Brewster's angle. Do you agree with that? બોલો sentence વાંચી લો. Brewster's law. શું હતું? When this angle is 90, the light is completely polarized, and in such case the angle is called which angle? Brewster's angle. Right? So this is Brewster's angle. Fine. So anybody n2 by n1, n2 n1 is equal to what? Tan 30 degree. That is 1/√3. But we know n2 by n1 is nothing but sin c. એવું થશે ને? Is that okay? See, for critical angle the light should be going like this to this. Don't forget that. But still, for that medium the critical angle will be defined, right? Okay, so what this gives you is n of medium upon n of air is equal to 1/√3. That's ખાલી ઊંધું લખાય. ઊંધું લખ્યું ને? હા. So here we'll get ના એક મિનિટ વેલ્યુ ખોટી આવી. n2 by n1. So n of medium upon n of air. આવું કેવું medium? મેં વેલ્યુ ખોટી આપી દીધી ઉતાવળમાં એવું લાગે. This can't be 30, right? Because air કરતા ઓછો થઈ જાય ને. Make sense? એનો ખબર પડી. 1 is refractiveness of air. You can't go less than that. Clear? એટલે આ વેલ્યુ વધુ આપવી જોઈએ. It should be something like more than 45 degree actually. તો જ થાય. સમજ પડે? ખબર પડી કે ન ખબર પડી? તો અહીંયા 60 હોય તો આવું થાય મારી જોડે. When I give numbers just like that, I always choose the wrong number. Okay, so you get n medium upon n air will be equal to √3, right? And then the critical angle can be found by sin c is equal to 1/√3. Okay, is this fine? એટલે problem શું થતું હતું કે n of medium was less than 1, which is not possible, right? એવું થતું. Try this one now. I just draw one diagram. Okay, you follow it similarly. Let's say this is unpolarized line. I will draw a Okay, if you draw it, you will be able to learn. Understand it very easy. Here you will get polarized. Number 1, and then there is number 2. Curve. So I say 3/0/8. हाँ बराबर. Okay, so if this is unpolarized, if it will pass through first Polaroid, again so then you say I0 by 2. Okay, okay. Clear? First step. Now time for second step. If it will go through this, now this time what's going to happen? See, the electric field of this light here will be same as the pass axis. Is that fine? In the same direction. All the random pass axis will cut it out. एक ज रही है. Okay, in one direction. Now the second Polaroid has its angle, has its pass axis at how much angle? 30 degree with the first one. એટલે આ બે વચ્ચે 30 બચે. Yes. Sure, that's clear. So now if this angle is 30 and this is I0 by 2, so now we have to use Malus law. When to use Malus law? When polarized light passes through polarized. Okay. So that's why here you will get I0 by 2 cos square 30. Clear? Okay, so that's going to be your final answer. પછી આ કરશો
5 minus 2 tan inverse 10 inverse 2 by
વાંધો નહીં ચાલશે tan inverse
180 minus 2 tan inverse 2 by
કરી દો એક્ઝેક્ટ એટલે એવું કંઈક આન્સર આવો જોઈએ લાગે. Draw the diagram here. This is a combination of ray and wave optics. Okay. હવે ખાલી હું ડાયાગ્રામ દોરા. Let's finish this problem. Gardening. Take your ass. ખાલી હવે પેપર્સ કરવાના છે બધા પેપર ની પ્રિન્ટ કાઢી લેજો જો ન હોય તો ફર્સ્ટ ની નહીં હોય ને કદાચ તમારે ઓકે ડાઉટ હોય જોઈ લેજો પૂછી લેજો. So this is what we are having in this question. અહીંયા √3 છે અહીંયા 2 છે. Okay, we have to find what is the angle of deviation. So do you agree that when light is reflected like this, the angle of deviation for reflected light is 180 minus 2i? I છે. Okay, so when it will get deviated, our deviation થાય ને. What is meaning of deviation? How much it turns? I'm just it turns like this. So this is deviation. Yes or no? Very covered now. Yes. Sure. This is deviation. So our delta then our 180 right? If you consider it a straight line, so they give 180 minus 2i is delta. Clear? This is for reflection. For reflection, deviation is always 180 minus 2i. Our question was the reflected light is completely polarized. So we can find I is just going to be theta b. How much? Tan inverse n2 by n1. Okay, so I'm going to answer now. Understood?
So second pass axis 90 degree.
So
Cos axis 90 degree plus.
Second and third okay. 45 45 45 okay. 1 પછી આ 45 કરશો. This question clear? ચાલો હવે વાંધો નહીં આ રાખો બસ ક્વેશ્ચન લખી લો પછી આપણે કાલ કરી લેશું સૌથી પહેલા યાદ કરાવજો પેપર સ્ટાર્ટ કરીશું એ ટાઈમ એન્ડ શોર્ટ મેં કહી રહ્યો જોઈ લો હા ડાઉટ પેપરમાં આવો વાંધો શું કહ્યું